that. Thanks, Chad. Actually, I did just change the name of this presentation because the chart has gone up. So this is actually now the intelligence revolution. So a little bit different, but still reasons to be optimistic. My name is Mike Granis, co-founder of Contango Digital Assets. Before we get started, I'll just share a little bit about us. We have two businesses under the Contango umbrella. One is a venture capital firm. We invest at the intersection of blockchain and AI. And we found Bittensor in 2023, mid-2023. And we figured it was a bigger opportunity than just an investment in the fund. We really wanted to roll up our sleeves and start building. And so we launched Contango Labs. It started off as a way to shepherd some of our portfolio companies into the Bittensor ecosystem and help them set up subnets. So we launched, we hired a team of Bittensor native developers, and we started building joint venture partnerships with our portfolio companies to help them get into the ecosystem and kind of accelerate their path to mainnet launch within about 60 days. Then we launched a bit of a mining operation, which is still in its early days, but we are mining across 3 subnets right now. And we also are the 50% owners of Roundtable Validator, which at the moment I think is the 6th largest validator on the network. But we also do some validation as a service for other subnet owners that don't want to run their own infrastructure. So the express goal of all of these companies within Contango Labs is to accelerate the value of our TAO-denominated assets in the company. But enough about us. Can anybody tell me what this chart represents? If you know the name of it, shout it out. If you don't, no worries. This chart is Moore's Law. So essentially what this says is the computing capacity that we can put on a single chip is doubling every 2 years. And this is actually the law that led Ray Kurzweil, a great inventor, to make incredibly accurate predictions about the future of technology and when they will happen. He also invented dozens of household items that we use every single day, like the scanner, text-to-speech, and many others. So today we're going to take a page out of Ray Kurzweil's book. We're going to look at the past, and then we're going to make some predictions about the future and the intelligence revolution that we're coming into today. But most people think Moore's Law is the only law that is leading to this exponential growth in AI, but what most people don't realize is that AI actually sits at the intersection of 5 exponential curves. There's an exponential growth in the amount of compute investment every single year, scaling up to about $1.8 trillion by 2030. Exponential growth in the amount of data that we're producing every single year. Exponential growth in the amount of spending on human reinforcement learning. And exponential growth in the open source services market. Also exponential growth in the amount of lines of open source code. So we're really sitting at the apex of all of these exponential curves and driving headfirst into the intelligence revolution. Whenever we have a technological revolution, it's always a good idea to take a look back at the past and understand what has happened in other revolutions and how to best position yourself for the next one. So let's talk about the core inputs, because every industrial revolution or technological revolution has core inputs. And there's 3 in this revolution. The first being compute, which you can think of as the heartbeat of AI. The next being data, which you can think about the senses, all the sensory information that the AI is pulling in. And algorithms, which are like the thinking brain that takes that data and makes inferences or decisions about it. So these are the core inputs of this industrial revolution. But let's take a look back and let's learn from the past. The first industrial revolution, or actually this is the second, but the core inputs of this industrial revolution were oil, steel, and railways. And what this led to was the commoditization of machinery, which eventually led to the commoditization of goods. This brought titans of industry. Brought some of the biggest companies in the world, Standard Oil, US Steel, and all the railways. But when you look back at the Industrial Revolution, there was really one clear winner. And that was, does anybody know this guy? JP Morgan. The original monopoly man, which is actually true. And why was he so successful in this Industrial Revolution? Well, a few reasons. He vertically integrated the core inputs. So he bought US Steel, Standard Oil, and all the railways. He owned the means of production, and he owned the distribution network. By the end of the Industrial Revolution, he owned 20%, or he had financed 20% of the railways in the country. So he owned the network. The digital revolution. 3 core inputs: internet, software, and microprocessors, led to the commoditization of information. Also led to titans of industry. But if we're going to look back on the digital revolution, you can make a fair case that the core winner is Bitcoin. And why is that? It vertically integrates the core inputs, it incentivizes the means of production, and it incentivizes ownership in the network. Same core principles. So let's look forward to the intelligence revolution. 3 core inputs: compute, data, algorithms. Leads to the commoditization of intelligence. Yes, it's going to lead to titans of industry, but I'm here to make the case that most likely the outcome is going to be TAO being the outright winner. Why is this? Let's recap. Vertically integrated, means of production, owning the network. This is for the industrial revolution, digital revolution. Vertically integrated, incentivized means of production, incentivize ownership in the network. Bittensor is really all the above. Vertically integrated, it allows you to own the means of production, because if you're a subnet owner, you're owning the digital commodities, you're owning the production of those digital commodities. It also incentivizes the means of production through mining, and then also incentivizes ownership at the parent level in the network, TAO. So let's look to the future. I think everybody in this room most likely knows the risks and the perils of centralized AI. That's why you're here, and congratulations for being so early. But I'm here to tell you that, yes, there is a better way. It's not just centralized versus decentralized as a moral imperative, but I'm here to say that decentralized AI actually outcompetes centralized AI across all 3 of those core inputs. And so it's not just the pragmatic decision, but it's also the philosophical decision to be decentralized. And let's talk about those 3 core inputs, and let's talk about what we've learned over the past. Well, Bitcoin showed the world that decentralized compute scales much faster than centralized compute. Bitcoin is the largest supercomputer on Earth by 500 times, and it's only about 15 years old. And so this is the chart of Bitcoin's hash rate. It's probably the most incredible chart in the world, and it shows just incredible vertical growth in the amount of compute that is on the network. So in terms of raw operations per second, Bitcoin is about 500 times more powerful than the next supercomputer on Earth. So decentralized compute scales faster than centralized compute. Let's talk about data. Decentralized data not just aligns incentives, but it aligns outcomes. So, we all know data is the new oil, and for the last 30 years, we've had the kind of wool pulled over our eyes by big tech companies who have owned and monetized our data off of our backs and made trillions of dollars off of it. And how much have you guys seen of that? Probably 0. And so with blockchain, we can actually own our own data, we can be incentivized for it when it is used, and we can actually take back control and ownership of that. But it's not just about the incentives, it's actually about the outcomes as well. So when you have a centralized workforce in one place that's doing the fine-tuning and the training of the models, you get poor outputs. So this was, I'm sure people saw about Gemini when they first launched, and people were asking about the founding fathers, and you had some pretty historically inaccurate outcomes. And this is because the force that were training those models was very centralized. So the more distributed, decentralized the people that are training those models, that are providing feedback, the better outcomes you get. So that's compute and data. Let's talk about inference. Open source AI is actually scaling, getting better faster than closed source AI. So this bottom line here talks about, this is all open source models and the rate of progression. And then the top private line is the closed source counterparties. And what you can see is that the open source models are already starting to get on par, and in some cases surpassing their centralized counterparts. DeepSeek was really what blew the lid off of this for the world. But there's nothing to say that this trend won't continue. And open source AI will likely be the outright winner, just in terms of sheer performance. And what Bittensor does is it kind of acts as a black hole that pulls in all the best decentralized models or open source models because miners have an incentive to just use the best model at any given time. It's going to increase their profit margins. So Bitcoin acts as a black hole, or sorry, Bittensor acts as a black hole. You actually have better performance, better outcomes when all those three core inputs of the intelligence revolution are decentralized. And Bitcoin was really the blueprint for this. So we all know the similarities between Bitcoin and Bittensor. Bitcoin's proof of work, Bittensor is proof of useful work. It's bringing that compute and doing things that are useful for the real world as opposed to just mining SHA-256. The consensus mechanism, I believe these are the crown jewels of both of these ecosystems. Nakamoto brought network consensus amongst a wide group of people. Bittensor brought Yuma consensus, which is actually really important for creating AI because it allows you to derive social consensus for outputs that are not binary. But here's what got me into Bitcoin that also got me into Bittensor, and it's the religious values. And it's very difficult to argue with the religious values of both of these ecosystems, and that's why I'm so bullish that they'll succeed, because it's not just a protocol, it's not just a technology, but it's also a religion. Let's look at Bitcoin. The religion pretty much just says separation of money and state, permissionless access, predictable monetary supply, and decentralized control. The values of Bittensor are very similar. Separation of AI and state, permissionless access, fair and open markets, and decentralized control. But where it gets really interesting is where they're different. And I believe this is the scaling law. So the network effects. Bitcoin is the first currency to ever scale with Metcalfe's law. This is a law that's used to talk about the scaling of telecom communications based on the amount of nodes in the network. But I believe Bittensor can scale on Reed's law. So what does that mean? Metcalfe's law says that the value of a telecom company or the value of a network will scale based on the amount of nodes squared. But when you add subnetworks to a network, and now we have subnetworks within subnetworks within a network, you can actually scale with Reed's law. So Reed's law says when you have subnetworks within, you scale at 2 to the exponent of the number of nodes in the network. So it actually has the potential to scale a lot faster than Bitcoin did. Now, I know predictions are a fool's game because if you're right, it was obvious, and if you're wrong, you're an idiot. But let's talk about a little price prediction today because it's the first Endgame Summit, and why the fuck not? Fastest assets to $1 trillion in market cap. As you can see, Microsoft took 44 years, Apple took 42 years, Amazon took 24, Google 21, and Bitcoin was the fastest asset of all time to $1 trillion in 12 years. Talking about what we've learned today in the industrial revolutions and the intelligence revolution, what do we think Bittensor is going to take to reach $1 trillion in market cap? We know this has scaling laws that can potentially outcompete Bitcoin. We know there's already a cryptocurrency market that has been established by Bitcoin. Let's make the assumption that Bittensor hits $1 trillion in 10 years. The first block was mined January 3rd, 2021. So by 2031, we'll have about 16 million TAO in circulation. And so that would make the price of TAO, drum roll please, by 2031, $62,000. So position yourself accordingly. Thank you.